Okay, let's go ahead and get started. So, welcome everyone to this week's Weathinar or weekly weather webinar, however you would like to say it. So, at these webinars, just as an intro, we go over the weather factors that are going to be important for your operational and financial decision making over the next 6 months, based on what the long range forecast looks like. And so, at today's webinar, we're going to specifically talk about supply chains. And to help me, we have a very special guest, Sadie Frank, who is founder and CEO of N4EA, and really excited to talk to her all about the effects of weather on supply chains, look at some examples in the past, and take a look into the future in terms of what is in store for supply chains going forward. So, to introduce Sadie, she is an expert on supply chains. She is a Yale Program on Climate Change Communication Fellow, and she's just a specialist in climate-related financial risk. And her company, N4EA, is doing some awesome modeling of supply chain risks, including the risks that are due to weather events. So, really excited to have her here. And in terms of who I am, in case this is your first webinar, so I'm an Earth System scientist. I am a former U.S. Department of Energy fellow, and I'm a former professor, and I am CEO and co-founder of Planet AI. My co-founder and I decided to start Planet in order to really be able to bring the best in the latest Earth system research from the research world to the real world to help folks across industries make better decisions in terms of what the weather has in store. So, welcome. Before we get started, I'd like to just say a few words about the kind of modeling that we do. So, the kind of modeling we do is long range modeling. So, this is very different from kind of the 7-day weather modeling or 14-day weather modeling that you're used to. So, a usual weather forecast happens when we run an atmosphere model. And so, this is kind of a schematic of what that model looks like. These are still big models, but they only include the atmosphere. The atmosphere forgets where it started from in 14 days. Hence, these models only have forecasting skill for about 14 days. When we want longer range forecasting skill, either to look at climate or to look at weather over the next weeks to months to seasons, or even decades, we use Earth system models. And these are much more comprehensive models, and they really take advantage of the fact that, unlike the atmosphere that forgets after a couple weeks, the ocean has years to decades to centuries of memory. The land has a lot of memory, the ice has a lot of memory, and together, by using these different components, we can model much further into the future. Please keep in mind, we cannot model day to day, but we can model week to week, month to month, season to season going forward. So today, as we talk about supply chains, I'm going to hand it over to Sadie so she can tell you all about supply chain vulnerabilities to weather. Then we'll talk a bit about the Panama Canal, which is very weather vulnerable. We'll talk a bit about cold snaps. And then we'll talk about disruptions in Southeast Asia due to extreme precipitation. So now I'm going to turn it over to Sadie.
Awesome. Thanks so much. And thanks so much for having me, Hansi. And really excited about the work that Planet is doing, because coming from the climate risk world, this question of long range forecasting and looking at subseasonal levels is so important for improving our understanding of climate and weather risks to operational factors. So love what you guys are doing. Thanks for having me. So what I'm going to be doing today is talking about how supply chains are impacted by extreme weather and climate. But first, wanted to kind of set the stage around what is supply chains and what are their vulnerabilities, because depending on who you talk to, supply chain can mean 1,000 different things. But just to kind of ground us in why supply chains are so critical and how vulnerable they are, the key thing to remember about supply chains is that they are a closed system. So we live on planet Earth. There are 6 to 40 key choke points that impact ocean freight. 92% of everything is on a vessel at one point. So these are incredibly important systems that rely on planet Earth for their function. Importantly, if there's a disruption, because it's a closed system, these impacts cascade across the entire supply chain. So they are nonlinear, they propagate, they cause disruptions to increase. Research has shown that a port disruption can blow up the impacts of a single disruption by 3 times when it comes to looking at the financial impacts. So these disruptions do not stay localized. They are both temporal and they are spatial in extent. So just to kind of give you a canonical example from my life, last year in the Gulf, we saw 2 massive back-to-back hurricanes in Helene and Milton. Those hurricanes knocked out a saline factory, a plastics factory, that turned out to be the main supplier of, I think it was like 90% of the world's IV drip bags. So localized event happened in the Gulf. Fast forward a year, I'm getting a procedure in Oregon in the hospital, and they've completely changed my procedure hydration requirements and in terms of like what I was allowed to drink. And I was talking to the nurse about that, and I asked her why, and she said that it was because of the hurricanes that happened last year. Because they had a shortage of saline bags, they had to completely redo their admitting procedures for hospitals all over the United States, including in Oregon. So I think that that is just the perfect example of how these localized disruptions do not stay local and impact all of our lives on a day-to-day basis. So really quickly, just to kind of talk through what these vulnerabilities look like. A lot of the times you'll hear people talk about asset level risk with supply chains. So this is like the flood risk to a specific factory in terms of the next, 30 years or in the next like 2 weeks, what extreme rainfall looks like at this specific port. This is what most climate risk assessments today focus on. Analysis methods to be able to understand these vulnerabilities include tier mapping. So, looking sort of into your supply chain to understand what your upstream exposure is, all the way down to some shoe factory in Taiwan. And then hazard analysis, mapping those assets in and looking at how climatic variables will change, how that will drive risk. Today, I will say that these are mostly focused on disclosure applications, limited strategic and operational implementation to date, but that is rapidly changing, which is good. And I will say that tools like Planet help us get a much better handle on what the operational, day-to-day impacts are on these assets. Next slide. But then the key, and this is my domain, so this is what N4EA focuses on, is the network level risk. So how these risks actually move through the global economy is focused on logistics and transport networks. So that's ocean shipping, rail, trucking, air freight. And this is actually where that magnification effect comes in, because as I mentioned earlier, localized events do not stay local. And this is actually when you talk to supply chain managers where their primary focus usually is. Because if you talk to supply chain guys, the two pillars of their world is what is my stuff and where is it? And that's kind of like all that anybody really cares about once it comes down to brass tacks in supply chain. And interestingly, this is a really underanalyzed risk from a weather and climate perspective because there has been so much focus on assets. And it's also just a harder technological problem to crack, which is what we're really doing at N4EA, is bringing in a very specific analytical toolkit to be able to understand and quantify the impacts of these network level disruptions. So next slide. So finally, to kind of just wrap on what supply chain risk looks like, I wanted to touch quickly on demand. Is demand and consumer level behavior like actually a supply chain problem? We can talk about that, but really it's very important because it comes up a lot in terms of how climate change impacts things like inventory levels, company planning, enterprise resource management, strategic factory locations, all of that. And the crucial thing is that climate change and weather are starting to really impact consumer behavior. So whether or not that's demand patterns around shifting desire for, Hansi and I were talking yesterday about the difference between like ski resorts having to switch to mountain biking because there's just like not as much snow, but also, as we all know, impacts around like air conditioning demand on grid stress, retail spaces. So in places where there's not a lot of air conditioning, that can really drive a lot of consumer behavior during heat waves. So just a critical thing to keep in mind as we talk about supply chains. And I guess back to you,
Thank you,
Hansi.
Sadie. Yeah. So much of this is about human behavior, right? Which is always the hardest thing to model. Yeah, I prefer the weather. So, coming to thinking about some specific examples here. So let's start with the Panama Canal and kind of look at some of the weather risks here. So, in particular, surprisingly, this canal actually, the locks in this canal actually run on water from a freshwater lake. This is a lake called Lake or Gatun Lake. And Gatun Lake has major year-to-year level fluctuations that are driven by droughts within this location. In this figure right here, what I show is essentially what is expected in terms of precipitation over this area of Central America. And in particular, this precipitation response is scaled by temperature. And so the whole idea is like, already we hypothetically are seeing some decline in precipitation over this year, even if it, or the right now, because our planet has already warmed about 1.5 degrees. Going into the future, it's not a matter of if there's going to be a reduction in precipitation in this region, but how much, based on how much our planet warms going into the future. And so this area is, just by construction, extremely vulnerable. So hand it over to you, Sadie, to tell us about those vulnerabilities.
Yeah. So if you know anything about trade, the Panama Canal is one of, as I mentioned, those like top global choke points. It is incredibly important to the global economy. 5% of overall global shipping goes through the Panama Canal any year. Crucially, we have designed Panamax class vessels that are designed to fit within a couple of inches of that canal, specifically for the lock system, which is a really great example of why you need planners thinking about these asset allocation decisions, because those boats are still being built today. Okay, so those are like 30-year-long assets that are being built today for a world that does not exist anymore. So just like a perfect example of why climate planning is important when you're allocating money. But just to wrap that up in real world, over the past 2 years, there was drought in the Panama Canal. This reduced the daily sailings. The canal had to implement restrictions, reduced cargo capacity, spiked freight rates, caused longer routes, was a huge issue in global shipping, and honestly was part of in inflation in terms of the inflation that you and I experienced. These kinds of things directly feed into that. So just like a massively impactful thing to have be disrupted. And actually, on my screen here, I wanted to show you guys some of our network analysis. So these figures show both the impact of a Panama Canal shutdown on a critical East Asia to East Coast United States trade route. So the top one is what it looks like when you shut down the Panama Canal. And then the bottom one is what it looks like when there's a Panama Canal drought. And then there's also a disruption to that critical Atlantic trade rate coming out of the Panama Canal into the East Coast. So what you see here is just like massive congestion effects as everybody's forced to use the Suez and go through the Mediterranean. This just as a quick example of this, when these events occurred, this spiked carbon emissions along these routes 116%. So these are like hugely impactful disruptions, both from a sustainability perspective, but also from a financial and operational perspective.
Wow. Okay. So, continuing to another type of weather event. So, moving on from droughts in the Panama Canal, let's take a look at cold snaps. So, it turns out that late September, early October, we actually have had some very cold temperatures up in Siberia, in northern Russia. And so when these types of cold snaps occur in Eurasia, often we see disruption of natural gas and oil facilities. In this case, there was less disruption and there was more record-breaking demand for natural gas domestically within Russia. And in particular, at this point, Europe has been relatively warm. And so there hasn't really been a huge need for natural gas. And so because of that, we didn't see any major price spikes. But if we had seen high demand over Europe as well, we would have certainly seen price spikes. And Gazprom, once again, mentioned record-breaking demand. So whenever, these types of weather events happen, they can, disrupt energy production and therefore disrupt energy markets globally.
Awesome. This is fun. I mean, it's not fun. It's horrible disruptions, but it's great. It's great to dive deep into some real world examples. And this one is actually one that I also experienced. So cold snaps are really important because anytime you're in a region that is unused to dealing with particular weather patterns, and there is a change, even if it's marginal compared to what you and I might experience in other locations, it can be hugely impactful. So last year, we were again, in the Gulf Coast, very vulnerable region, for some client meetings. And this was when there was this massive cold snap. And what ended up happening it was like record snowfall along the Gulf Coast. And what ended up happening was that you got disruptions across the entire supply chain. So even though it was like minimal snowfall, we're talking about like Florida and Texas. And so airports shut down. Um, Road networks experienced ice that, in a region like where I grew up in upstate New York would have been no problem. But down there, it was hugely impactful. Also caused, interestingly, chemical and energy factory slowdowns. So you had both that asset level risk that we talked about earlier, but then you also had transportation network effects that caused cascading disruptions. We looked at $14 to $17 billion in total losses from that one event. Interestingly, mostly driven by impacts to the airports. So again, that's an example of how you get network and asset level effects, but it's really oftentimes those transport impacts that drive the majority of losses.
Yeah, that's a really good point, Sadie. I mean, so much of this is not just, is it cold, but is it cold for
Yeah,
that particular location, right? And so, based on kind of that relative coldness, that's what's going to determine the impact. Obviously, cold in Siberia means something very different than cold in Texas. Yeah.
totally.
So finally, we want to touch on precipitation in particular, and particularly extreme precipitation. So the canonical example here is Thailand 2011, where there were these major floods. And so back in the day, just a teeny anecdote, I was a graduate student looking for a giant hard drive for storing all of my Earth system data. And at that time, I had budgeted a certain amount, 6 months earlier. And then when I went to go purchase it, the price was twice as much. And I remember being on the phone talking to this operator, being like, why is it so expensive? How can the price go up, double in a year? And literally, he said, oh, there's floods. So, here we are, like not floods anywhere where I was located in Seattle, but floods literally, across the world impacting me half a year later. And so I think it really just highlights how supply chain effects are really kind of dispersive in space and in time and really have these ripple effects. So these floods, they caused 40 billion in losses, resulted in major supply chain shocks, particularly for these hard drives, but also for automobile manufacturing. Toyota suffered huge losses that year. Literally, those floods caused a 2.5% decline in global industrial production, which is just kind of mind blowing that a particular country that was flooded for a little while led to such a large scale effect globally. And global GDP growth was actually revised downward from these floods. It was expected to be around 4%, and it was revised down to 3%. So, you can kind of just see how these ripple effects have such huge effects on our financial systems globally.
Yeah, and just to sort of bring us home here on the extreme rainfall, and wanted to emphasize, in addition to the fact that supply chain disruptions are dispersed across time and space, they also stack and they have huge co-occurrent factors. So the Philippines is a great example of this. So the Philippines is a Southeast Asian country that is at high risk of a variety of different hazards. So intense rainfall, earthquakes. It's also very critically located for several um, geopolitical tensions, particularly around like China and Taiwan. It's in critical shipping lanes there. So this is a country that is highly vulnerable to a variety of disruptions, but is also very important to several critical industries. So I know we have semiconductors on the brain. The entire world does, particularly right now with what just happened with Trump and China. But the Philippines is a main global assembler of chips. So, while it is a manufacturing, agriculture, and tourism hub, it is also, highly impactful in the entire value chain of this critical industry. So, something to definitely keep an eye on in terms of trying to understand both the way that these global risks can stack on top of each other, but then also to think about, okay, what exactly is this place doing in the context of critical industries? Because again, might not show up on the list of like, it's not Taiwan. There's not a ton of, focus on it in terms of semiconductors when you sort of hear about it in the news, but it actually turns out to be this key node for this part of the semiconductor value chain.
Mm. Yeah, that's super interesting because whenever we think about semiconductors, I don't think Philippines, but then
Yeah.
yeah, given the fact that that node is there, it's pretty critical. So yeah, these kinds of stacking effects I think are really important because right now we don't predict earthquakes, but yet this region it has experienced intense rainfall, storms, so particularly Hurricane Rugaza or Typhoon Rugaza, and then earthquakes. And as we'll see in the next slide, November is going to be higher than usual precipitation this year over this region, particularly because the MJO is moving over or MJO precipitation is moving over this region. So really, this region is very vulnerable. We will continue to keep our eye on the forecast over this area because, once again, critical to supply chains and really experiencing kind of a lot in terms of disruptions right now. So a few other implications in addition to thinking about the Philippines. So also wanted to point out once again, we have a high likelihood of cold snaps this winter, partly because of the state of the stratosphere. Also, as Aiden, our stratospheric specialist, has told me, there is also, because Siberia is experiencing a cold snap and has been much colder than usual over the past month, it's really preconditioning us also for polar vortex weakening. So just keep that in mind. We'll keep an update on the state of the stratosphere. We'll let you know what it looks like every week. We don't yet see, some major weakening event happening, but we will let you know as soon as we do. And then finally, just to touch base about Panama. Panama is not looking problematic this year, but going forward, the long-term outlook isn't great. So maybe not something that you want to expect to be, dependable for, decades into the future. So it'll be really interesting to watch how networks adjust to that particular climate risk because it's not a matter of if, it's just a matter of extent and when. So finally, thank you all so much. That concludes today's webinar. And so please stay tuned for next week's, which is going to be on the science of long-range weather and essentially both strengths and limitations of this technology and how it can be used reasonably in terms of an overall financial decision-making strategy. If you're interested in learning more about what Planet does, feel free to contact me, Hansi at planet.ai. You can find both me and Sadie on LinkedIn. And if you're interested in anything that either of us do. And then finally, I post a lot on LinkedIn specifically about the intersection of weather, climate, and financial markets. And so please keep track if you are interested in this intersection. Thank you so much, and we'll open it up to questions in case anyone, yeah, has some things that they're wondering about. I see a lot going on in the chat over here. Ah, thank you, Sadie. Sadie has her email address posted. Ooh, okay. So, Alex Korb says that supply chain shocks can be hedged via innovative parametric insurance solutions. Alex, I would love for you to say a little something about that if you're able.
Sure. Hello, everyone. No, this is just an observation, partly Hansi. Hello. I appreciate seeing the last minute notice about this event. This is partly a biased view from a practitioner in this field, but supply chain is front and center in the broader arena that is called non-damage business interruption. And this affects basically transcends the industries and the regions and perils and the company types, you name it. And so this is a very kind of a pressing issue, which is discussed in insurance and risk management circles pretty much everywhere, at least where I go. And so, an important part, in addition to providing a clear picture of what's happening both factually as well as forward-looking through forecasts, near term or long term, at the end of the day, you would want your customers to do something with your information, right? Even if you're strictly in that information provision business. And so doing something really boils down to two things. Can you, in case of an inventory example that Sadie has mentioned, which is something that's been used in retail industry for years by some progressive companies, by far not by anyone, not even close, but you can leverage these types of insights to shape the decision of on your inventory, on your discounts, on your staffing levels, on where you put stuff on the shelves if you see that there will be a cold snap coming in 2 weeks, because all of those things drive consumer psychology and that drives demand. Forecast drive consumer psychology more so than the actual weather, right? You hit the stores looking for the shovels in the Home Depot when you know the storm is coming, not after the fact, right? And so all of that is important, and that's one way to monetize that decisions and information by making it easier for recipients to do operational decisions. But equally important, and sometimes more important, especially if you speak to the CFOs, is the financial side of the coin. Even if you do everything in your power to adjust your inventory, etc., there is still bad stuff that's going to happen that's going to hit your earnings and potentially capital. And what do you do then? Particularly so with a supply chain disruption, especially some of those very good examples you listed earlier, where effects persist for years after the fact, right? And the good news, especially let's just say over the past 5 years, is that there is now a robust suite of solutions, financial solutions, which companies, large and smalls, governments, large and smalls, could and should, and many in fact do use them to basically ensure that they are financially resilient, to mitigate those things. And I'm sorry, I didn't mean to monopolize the time of lecture here, but just an observation that it's a very important element to go along with provision of this, forecast data and insights into the weather and climate.
Yeah,
Yeah,
absolutely.
absolutely.
Oh, go ahead, Sadie.
No, I was just going to say you're absolutely right, Alex. And I would say that I would love to see many more companies innovating around parametric in particular, and thinking about how to leverage data sources like what N4EA provides and what Planet provides to build these innovative financial transfer mechanisms. Because yes, totally, there's lots of opportunity to innovate around financial risk transfer for supply chain. We have observed that depending on who you talk to in the industry, there's more or less appetite for trying something new when it comes to building these products. But the opportunity is there, and I think it's only going to grow.
Absolutely. And the only other thing I would mention is that the cutting edge in that arena is solutions which are actually driven by forecasts themselves as opposed to by the actual data. The so-called forecast-based parametric solutions, where precisely payouts are made based on short-term or long-term predictions. And that is sort of taking the power and versatility of what could be done to a whole different level, because you get money basically before something happens.
Yeah, right. So basically, preparation for what potentially the disruption or the disaster might be. And so, to take possibly appropriate operational measures to decrease costs. Yeah, that's a really interesting way of kind of looking at some of these problems. I think one of the questions I always have is like, at some point, I mean, the risks get really high and get really expensive, right? And so, I don't know. At some point, there's always the question. I mean, there's a reason why it's almost impossible to get earthquake insurance in California, right? Because it's just.
You can get it on a parametric basis right now from multiple providers as a residential homeowner in
But
California.
but does it pay for everything? Would it pay for my full losses if my home went down?
It will pay whatever amount you would want it to pay, right? In this
Mm,
instrument, you determine how much you get paid, and you get paid based on simplistically whether or not a quake occurs within a certain distance of your location, or based on the shaking intensity at your location. So if you estimate on the back of an envelope that in the event of a 6.5 within 50 miles of your residence, you're likely to incur X in terms of losses, including some extra expenses, not necessarily physical damage,
hmm.
because physical damage might be dwarfed by all the other expenses. Yeah, you basically would request a quote for that type of insurance with that type of limit, and you will get paid if a designated event happens.
Mm, great. Yeah. Awesome plugs for parametric insurance and creative solutions. Thank you all so much. We're at time, and you know where to reach us if you have any further questions. Thank you so much, Sadie, for being here. Sadie is
My
just
pleasure.
yeah, a treasure trove of like expertise in this area of supply chains and weather risks. So really excited about this conversation. So thank you all so much, and we look forward to hopefully seeing you next week.
Awesome. Thanks so much. Nice to meet everybody.